Okay, then you see there is a feedback resistors. There are two input resistors. So if you have resistors around the op amp, you will have the gain. Okay. So when this is look like inverting type, so you have inverting type gain. Okay. But here we have two input, which is one coming from V1, okay, the other one is coming from V2, and the current is flow in this direction, the current will flow in this direction, and at this point basically they meet and they sum up. So why this signal conditioning circuit is called summing amplifier, because whatever you have from this V1 and V2, when you reach the negative pin of amplifier, you are summing up this two things. Alright. So you have resistors around, you will have gain, and because you have two input, you have summation operation. Okay. So from the schematic, you can work on the derivation that relates between the input and output, but finally you will have the formula that reflects the operation of this circuit. In this formula, you have V out equal to negative RF. Why negative? Because this is inverting type. The input is connected to the negative pin of the amplifier. And then you have V1 over R1, V1 over R1, then you have V2 over R2, V2 over R2, V over R equivalent to I1, V1 over R1 equivalent to I1, V2 over R2 is equivalent to I2. So you are basically working with the summation of current from two sources, from a V1 and a V2. And when the I, you multiply by the RF, I multiplied by R, you have the V term. So V out will be more or less equal to something multiplied by the gain. The sum of current from input channel, from input source multiplied by the gain. Alright. So you can apply the gain, and of course from there you will have the output added from V1 and V2 sources. Okay, if you look at the circuit, you know this is a summing amplifier. Okay, so yeah, it goes like this as well. It's the same as like the RF is outside. In this case, we have the RF is the form is readjusted so that you can see clearly from this formula. You have V out is equal to V1 plus V2, each of the V multiplied by the gain for V1 is basically RF over R1. So this is a typical inverting kind of gain. So the gain for V2 is RF divided by the R2. So I think this form will be very much familiar compared to the equation in the previous slide. So you know basically if to have this kind of schematic, the formula is basically V1 plus V2, but there is a gain term that you need to work on. So that is the final formula for summing amplifier. Okay. For example, you have example 2018 develop an op-amp and can provide an output voltage related to the input voltage given by. So here they give you the formula V out equal to 3.4 V in plus 5 just there. So you know you have summation in this equation, so that will be related directly to the summing amplifier. So look at the solution. The summing amplifier is given the equation. We have to recall back the summing amplifier formula. So when you put in this form, you can straight away relate that P1 is basically this, and P2 is basically that, and have to relate this equation, you have to relate this term to the equation given in the question, which is going to the next slide. Okay, so in this case, basically let G1 taking the 3.4, and G2, in this case we assume RF over R2 is equal to 1. So Vin is V1 and V2 is plus 5 volts. Right, here basically you make assumption, especially on this term, because they don't tell you whether the 5 is basically the gain or the voltage. So in this case we make assumption. Okay, so now you have G1 RF over R1 is 3.4. So you have 3.4, you make assumption of these two values. Okay, and therefore now you have RF and also R1, and next we have to figure out R2. So G2 is taking the value here, and RF is there, RF is here. So you can basically calculate what is R2. So once you have all the what they call that, you have all the values from the circuits fulfilled. So that's why I mentioned you have to memorize the circuit. When you see a question talking about summing amplifier, you have to be able to redraw the circuits, put in all the active and passive components, and then find the value for this thing, and now you have a very complete circuit. Okay, so there's a yellow note down here that says the output is negative because it is inverting, so you have to make it positive again by adding another inverting amplifier circuit. This is what I meant. So from here, basically, you have a negative output, so you have to multiply by unity gain, G equal to RF over Rin, so RF is 1, Rin is 1, so G equal to negative 1, so you multiply by negative 1, you will have all positive output on this side. So that's the idea of why we put in this block. Okay, this block is just to make sure that whatever you have from here negative multiply by negative 1 meaning that negative sign is gain equal to 1, so there is no changes in terms of input when we pass through this circuit. And whatever happens is that the negative output of this circuit will be multiplied by negative 1, so that you will have positive values. So this unity gain inverting circuit is just required to change the sign of the signal. Alright. If you have any question, you can certainly ask, or you can type in the chat box down. Alright, so that is for summing amplifier. Next, we are looking at differential amplifier. So the same architecture of using the inverting type, because the input is connected to the negative pins. Okay. We have another input here, but this input is referred to the ground by R3, so I will simply charge this is negative type. You still have RF, and also the same, we have two input, V1 and V2, but they are not meeting at one point. So if you see V1 and V2, they meet at one common point, just like the summing architecture, the summing circuit. So you are talking about summing amplifier, but if you see V1 and V2 is not connected to a common point, they should be connected to pins. We're talking about differential amplifier. So differential amplifier basically finally the formula goes like this basically. Alright, you have Rf over Rin, Rf over Rin as the gain, okay, and V2 minus V1. This is just to differentiate between two inputs, whether if V2 is bigger than 1, you will have positive gain here, okay. You have positive gain. If V2 is smaller than 1, you will have a negative gain. Okay. So of course, because the formula goes like this, so you know whether this thing can be inverting and can be non-inverted, because it depends on which input is basically given. But this amplifier is trying to see whether V1 is bigger than V2 or the other way around. Alright. So for differential amplifier, normally we add unity gain or voltage follower circuit just for the impedance matching or put isolation, because the impedance is very high in this circuit, so almost no current pass through, so it's a matching circuit. Okay, so the final formula will go Rf over R1 means V2 minus V1. Alright. Okay, so that is, I think, for the differential amplifier. Example 2.2 here is output range of 20 to 250 millivolt, 20 millivolt to 250 millivolt as a reliable varies over its range. Develop as a conditioning circuit so that this will become 0 to 5. Circuit must have a very high input impedance. Okay, pay attention to this word. The circuit must have very high input impedance. This would straight away refer to the voltage following circuit. Okay, we are talking about impedance matching here. And there is a solution for the linear this one. So we have to solve linear equation between these two. We have the final linear equation, and I think you can work this thing out later on. Alright, I will not go through this. This is just solving the linear equation. But in all of the questions that talk about inverting or inverting within conditioning, you will have to have a full schematic in your head, which you have to reproduce in papers, and you have to get all the values of all the components around the op-amps, and then basically you have to have the formula, and from there you can calculate almost anything. Alright, that's the way to go. Next is voltage to current converter. Okay, there are situations where you need to voltage to current, and I think there will be a circuit to convert from current to voltage. So you can change this quantity of voltage and current by just providing this circuit to the system. This is voltage to current. Okay. The circuit goes like this, but voltage to current, we call that circuits. There are many types of circuit. This, I would say, this is just for your information. This thing will not be asked in the test. Alright, voltage to current, current to voltage is not going to be asked in the test, so you don't have to basically memorize this, because there is no standard schematics or circuit for voltage to current or current to voltage circuits. Depending on the manufacturer who fabricate the IC chips, they will provide a data sheet that describe that the circuits are different from the others. Unlike the inverting or non-inverting op-amp, they are all standards. All manufacturers, when they produce op-amp, they will have to follow the non-inverting or inverting circuit. They are standard, you can memorize that. But for this, there are many I would say, variety type of voltage to current, current to voltage circuits you have to memorize this, not even the formula. It's not going to be asked in the exam, but this is just for information. Alright. So for this particular circuit, of course, if you perform circuit analysis, you will have I and R relationship. You have, of course, going to this to relate between the input, which is the V in, and the output, which is the in, which is the current. So they are for this circuit, they are very much related by R2, R1, and R3 in this form. Okay, so this is another version of voltage to current. As I mentioned, there are many versions, many types. So we're not going to stick to one. So that's why we don't pay too much attention on this, because you can find many variety type of voltage to current or current to voltage in the converter. And basically all of the things can influence. So next is current to voltage converter. It's the same thing. You have current, but you want to convert to voltage. So you can basically use this circuit. Okay. And the formula is as simple as VR equal to input current that you give A multiplied by the feedback resistor R. Okay, so this circuit also will not as in test one. Okay, next is comparator. Okay, this one I think will be asked in the test. So you may want to pay attention to comparator, summing, and there's now different potential. Differential amplifier. So summing amplifier, differential amplifier, and comparator. So pay attention to these three because I think they will be included in the test. Okay, for voltage, yes, comparator. So for this comparator circuit, they compare between two analog voltages, the input terminal. Depending on which voltage is larger, the output will be 0 or 1. So the chip that uses is LM54. So the logic just goes like this. We have the VA and the VB, so we want to compare whether VA is bigger or VB is bigger, and just that. We don't care about bigger by how much or smaller by how much. We just care about which one is bigger. And if VA is bigger than VB, the output will be 1, the logical output is 1. If VA is less than VB, the logical output is 0. So we will be observing 1 and 0 in the output. If we observe 1 in the output, we know that VA is bigger, this line is bigger. If the output is 0, we know that VB is bigger. Okay, so example, process control system specify that temperature should never exceed 160 degrees Celsius. If the pressure also exceeds 10 kilopascal, alright, design an alarm system to detect this condition using temperature and pressure transducer with a function for both respectively. So we have the transfer function, we have the limit, the value of the temperature and the pressure. So basically we want to know this, because our circuit work on voltages, so we have to convert the circuit limit value to voltages. So we take 160 multiplied by the transfer function, you will have V temperature limit is 0.350 volts. For the pressure of 10 kilopascal, you multiply 10 kilopascal value limit to the transfer function, you will have voltage pressure limit is 2.0 volt. Alright, so you put in these two values in the comparator design. Alright, so whatever coming from P in over here, okay, they will be converted to voltage by what they call that, the transfer function, and the value that comes out here will be very much compared to the limit. This is for the temperature and this is for the pressure. So you have voltage down here versus voltage down here, so it's a fair comparison. Also you have voltage down here, voltage down here. Because here maybe you have temperature in degrees Celsius, also you have pressure here in kilopascal. So you have V with V, so you can do a comparison. Okay. So you have that now. So this is our full circuit because the question was asking if the temperature exceed together with the pressure exceed. So the alarm will only goes on if both are there at the same time, and therefore we have to work out the logic gate. This is the AND gate. Okay, this is the AND gate. So if the question was asking whether either one, so you should be working with the OR gate. Okay, so that's the different. Okay, so the OR gate I think goes like this. So this is input. This is the this is OR. OR gate is the AND gate, depending on what the question asks. So when you have that, normally the question would ask you to build a truth table. So output 1 and output 2 the alarm, so the logic coming from this side. So you have output 1, you have output 2, and the alarm. So this is the truth table for AND logic gate. So you take output 1, 0, 0, 0, 1, 1, 0, 1, 1, and let's see what happened to the alarm. So in this case, if both limits are exceeded, so you will have the alarm goes on. Right? So the question normally they will ask you to produce the truth table for the system. Okay, so di dalam test masuk pay attention to this thing. I think I'll skip the remaining thing because it's not exclude this thing in the syllabus and it's not in the test, so we don't go for it. Alright, so that's the scope that I want to cover today on my lecture. Any question before we proceed to other things? Guys, anybody? So just pay attention to three kind of circuit. You have summation just now, you have differential, you have comparator. Okay, that three circuit maybe will appear in your exam, in your test one. Alright? So kalau tak ada apa-apa saya nak move to the next agenda. I see some oh wow, macam mana apa yang saya sebut keluar kat sini. It's not 100% correct, but it's there. This is some kind of all the things that I see up here. Okay. Ada soalan ke tak ada? Caption itu terus okay, no question. So I'll move to the next thing that we want to discuss. Okay. Guys, actually my lectures are also available online kat YouTube. I think I can share with you my the link to the to my WhatsApp profile. WhatsApp profile kat about the profile about is there is a link to my channel, the YouTube channel. You can find all my lectures from the recommendation there. You can have a look at that lah. Okay. the next thing adalah akan projek sikit. Okay. Boleh nampak ke semua orang? Can you see? Yes, thank you. So I will share this thing in the WhatsApp group after this, so we can have a copy of this. So this is instrumentation project, 40% of your marks and the total marks. Alright, the title here says the development of instrumentation system for system monitoring and data logging. So there is no specific application mentioned in this project information, so meaning that the application is open. Okay, all you need to do is to fulfill a few criteria that I mentioned down below. I think the objective is to design and develop instrumentation system for monitoring and logging, to calibrate the proposed instrumentation system, to investigate the accuracy of the developed system of instrumentation. So you just to design, to calibrate the sensors, to investigate the accuracy. So it doesn't mention any application, it doesn't mention any sensors, it doesn't mention any transducers, it doesn't mention any kind of controllers. It's all open. You have to just demonstrate these three things, I think. No, there are some other things happening. Project rule and regulation. This is individual project. Everyone should submit his or her own project report, and the report should not contain any, of course, materialism. Please take note that individual project outcomes need to be different from the others in the following perspective: the instrumentation system, selection and design, material selection, fabrication, sensor calibration, chart and graph, accuracy information. Students are going to include. I think I have asked previously that you guys form up a group, 4 or 5 person for each group. Okay, this is your group. You can work together in your group. You can share things there, but produce your own project in your own report. Alright. Assessment report 30%, and really 10%. Presentation 10%. Okay. So for the report, you have 6 chapters down there. You have chapter 1, project background, technical scope, review, research technology use. Selected some. For example, if you use what they call that, some kind of speed sensor, for example, in your system, so you have to find technology that they have that makes up the speed sensor, or even the recent application of that sensor that you choose. Chapter 2, mechanical design. So you have to produce physical design, okay, circuits and all that. And chapter 2 here was asking about some mechanical design. So this goes to the design of enclosure, engineering drawing, proper dimensioning, material selection. If you are working with, for example, 3D printers, plastics, some of you may be working with the woods, some of you may be working with what they call them, polyglass, or any kind of acrylic. You know, you have your own preference in terms of they call it the box. So your circuits or your system of instrumentation must be placed in the box. You have to use engineering drawing, you know, like CAD or what, SolidWorks maybe to produce the proper design and dimensioning before you fabricate those things. Alright, so that is chapter 2. Chapter 3 is focused more towards the design, sensor selection, semi-conditioning system, schematic diagram, component selection, and if you have remote monitoring, you can please add them as well. Chapter 4, calibration procedure. Chapter 5, error. Chapter 6, conclusion. So this is things that you need to produce the reports. Number 2 is presentation, 10% marks there. So in a 3 to 5 minute presentation, you should be able to, maybe in the PowerPoint forms, background, system design and how it works, functionality demonstration. Okay. List of hardware down there is just general recommendation. You can use those and you can also ignore those if you have. Okay. Again, you can work in group. Okay. You have to mention your group. Okay. But you produce your own report, in which means everybody's project must be different from the other member of the group. Okay. Yeah. So maybe from after the mid-sem break, we will focus on project development for every group. Right? We try to finish off our lectures before the semester break, and after the semester break, we will be just discussing about history. Okay. So every week I want to basically see the progress and the work that has been carried out, okay, progressively. Okay. Any question regarding to this? Any question, anybody? No. So I mentioned it's some kind of open-ended, so you are not required to produce system of instrumentation in certain application, which you have to choose your own. Also, the type of controllers, the type of sensors and all that, you have to choose your own, you have to propose your own. So yeah, it's quite easy this time, because previously you have to focus on something, everybody is working on the very same thing, you have to be different, so that's difficult. Okay, so okay, we will go through these documents again after the mid-sem break before we start the project. This is just for your information. You can start, analyzing your group, and of course, you can start working out some preliminary study to start this. Alright. Okay, now that is all. Let's move on to our last agenda, which is tests. So test satu, alright. So basically you have two questions, question 1, question 2. Question 1 will be covering chapter 1 and 2 in your lecture, and question 2 will be working on lecture 5A and 5B. Okay, so lecture 5A and 5B, there is inverting, non-inverting, there is a summation, differential, and comparator. So that is for question 2. Question 1, just the general definition of system of instrumentation, general definition of the block diagram, general definition of accuracy and stuff like that. That's in chapter 1, chapter 2. I think chapter 3 and 4 is not included. You can focus your study in chapter 1 and 2 and 5B for test 1. Okay, for chapter 5 and B, again I mentioned inverting or inverting, memorize the schematic and the formula. For 5B, memorize the schematic and the formula for summation, differentiation, and comparator. Great news. Right, any question? Again, for question 1, lecture 1 and 2. We have some time, look at chapter 3 as well. Right, but there is no calculation for question 1, just definition here. There are some small, very, very small calculation that doesn't need you to remember any formula. Okay. Ada soalan ke so far? Any question? No question? Guys, can you hear me actually? Yeah? Alright, thank you, Chang. Okay, so kalau tak ada soalan, I think that's more or less it for the meeting today. Bila test 19. Bila test 19. Today is 15, so we have couple more days. So 19 is basically Sunday. No, yes, Sunday. Next Sunday. Okay. So kalau ada, if you have any, because our class is just today. If you have any other difficulties, you can contact me. We can have a special session just to prepare for test one. Okay, if you require this, just mention in the WhatsApp group that we will set up a time to meet online, to discuss things that are more specific to the test one. Okay guys, kalau tak ada apa, I think that's all for today for this meeting. I think we have covered enough for test one preparation, and of course project. This project briefing is just for your own information and preparation. We will start the project after the exam break. Okay, thank you everybody. Thank you. Thank you guys. Okay, I will try to find test one sample. Okay. Thank you. Just pay attention to the WhatsApp group. I'll be sharing all information there.